Hello, my name is Teja Srinivas and I'm here to explain you about introduction of polynomials and their types from the chapter Polynomials of class 10th. Firstly, what is algebraic expression? An algebraic expression is an expression made up of variables and constant along with mathematical operators. Here we can see that algebraic expression means it consists of variables and constants with mathematical operators like plus, minus, etc. An algebraic expression is a sum of terms which are considered to be building blocks for expressions. A term is a product of variable and constants. A term can be algebraic expression in itself. Examples of a term 3, which is just a constant. Here we can see number 3, it is only a constant, and 2x, which is a product of constant and as well as variable. And here you can see the product of 4xy, means 4 is a constant and xy are the variables. And here we can see 5x square y. Here we can see the product of 5 and 2x's and y. This is a called term. The constant in each term is referred to as a coefficient. And let's go to the example of an algebraic expression 3x square y plus 4xy plus 5x plus 6. This total expression is called algebraic expression, which is a sum of 4 terms. Here we can see 4 terms: 3x square y, 4xy, 5x and as well as 6. The 4 terms, the collaboration of these 4 terms forms the algebraic expression. An algebraic expression can have any number of terms. It can have number of terms. The coefficient in each term can be any real number. There can be any number of variables in an algebraic expression. The exponent on the variables, however, must be rational numbers. Let's go to the polynomial. An algebraic expression can have exponents that are rational numbers. However, a polynomial is an algebraic expression. However, we can see that in a polynomial there will be same as like algebraic expression, so it is also called an algebraic expression. Polynomial also called algebraic expression in which the exponent on any variable is a whole number. Here we can see 5x cubed plus 3x plus 1 is an example of a polynomial. It is an algebraic expression as well. And 2x plus 3 into root x is it is also an algebraic expression but not a polynomial. Yes, it is not a polynomial, since the exponent of x is, because it is not a polynomial, because here we can see the exponent of x is 1 by 2, which is not a whole number. Here we can see 2x plus 3x root x means x power 1 by 2. Here the expression is, it is not a whole number, so it is not a polynomial. Let's go to the degree of a polynomial. For a polynomial in one variable, the highest exponent on the variable is a polynomial is the degree of the polynomial. Polynomial means the highest exponent on the variable in the polynomial is called degree. If the degree of any polynomial is the highest exponent of that variable, and here we can say an example, the degree of the polynomial x square plus 2x plus 3 is 2, as the highest power of x is the given expression is x square, so the degree is 2. And let's go to the types of the polynomials. Polynomials can be classified based on number of terms and degree of the polynomials. Types of polynomials based on the number of terms. Number of terms, it consists of monomial, binomial, trinomial. Monomial means a polynomial with just one term. If it has only one term like 2x or 6x square or 9xy, then it is said to be monomial. If the polynomial has two terms like 4x square plus x or 5x plus 4, it has two terms, then it is said to be binomial. And trinomial means it has three terms like x square plus 3x plus 4. Here we can see three terms, so it is called trinomial. Let's go to the types of polynomials based on the degree. It consists of linear polynomial. Firstly, what is meant by linear polynomial? A polynomial whose degree is 1 is called linear polynomial. For example, 2x plus 1 is a linear polynomial. Here we can see the highest degree is 1, so it is called linear polynomial. If the highest degree is 2, then it is said to be quadratic, and if the highest degree is 3, then it is said to be cubic polynomial. Firstly, let's go to the quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. For example, 3x square plus 8x plus 5 is a quadratic polynomial. And let's go to the cubic polynomial. A polynomial of a degree 3 is called a cubic polynomial. For example, here we can say 2x cube plus 5x square plus 9x plus 15 is a cubic polynomial. Let's go to the graphical representations. Representing equations on the graph. Any equation can be represented as a graph on the Cartesian plane. We can represent any equation on a graph where each point of the graph represents the x and y coordinates. On the points here we can see x-axis and y-axis, and we should draw x and y coordinates on the equation. An equation can be seen as a constraint placed on the x and y coordinates of a point, and any point that satisfies that constraint will lie on the curve. Here we can see that if we can draw anything on a graph with numerical values. And let's go to an example. For example, the equation y equal to x on a graph will be a straight line that joins all the points which have their x coordinate equal to their y coordinate. Example, we can see 1 and 1 comma 1, 2 comma 2. So we should draw a line in such a manner y equal to x. Let's go to the visualization of a polynomial, geometric representation of linear polynomial. The graph of the linear polynomial is a straight line. It cuts the x-axis at exactly one point. It cuts the x-axis only at one point. Here we can see it cuts nearly at -2, something like that. Then it is said to be linear polynomial. If it cuts only at one point, then it is said to be linear polynomial. If it cuts at 2 points, then it is said to be quadratic. Here we can see the graph of the quadratic polynomial is a parabola. Means it cuts at 2 points. We should draw a curve. So the curve is in the form of parabola. It is a positive. Then parabola opens upwards, and if it is negative, it opens downwards. It can cut the x-axis at 0, 1 or 2 points. It depends on that problem. Graph of the polynomial which cuts the x-axis in 2. Here we can see the parabola cuts the x-axis at 2 points. And let's go to the next one. Graph of the polynomial which touches the x-axis at 1 point. Here we can see it touches at 3 only at 1 point. And graph of the quadratic polynomial which doesn't touch the x-axis. Here we can see the next picture, it doesn't touch the x-axis and it is downwards. And let's go to the graph of the polynomial x power n. For a polynomial of a term y equal to x power n, where n is a whole number, here the n is a whole number, means it can have 0, 1, 2 and so on n. As n increases, the graph becomes steeper or draw closer to the y-axis. Okay, when the n is increasing, it becomes steeper. Means it draw closer to the y-axis. It comes closer to the y-axis. If n is odd, the graph lies in the first and third quadrants. If n is even, the graph lies in the first and second quadrants. And in such a manner, it depends on the n value, so that it can be at first or second, or first or third, or it can be steeper, like means it can be closer to the y-axis. It depends on the n value. The graph of y equal to minus x power n is a reflection of the graph of x power n on the x-axis. X power n is the reflection of minus x power n. And graph of the polynomials with different degrees. It depends on the different degrees. Here we can see that graph y equal to x square and y equal to x power 7. Here we can see that it is in the first and second quadrants, and as well as in the third quadrants. So this is called the graph of polynomial x power n. And thank you.